we were to ask any middle school student which of the four basic operations inspires the most fear, apprehension, and/or hatred, long division would win in a landslide. Students have a lot of difficulty with long division for some very understandable reasons, not the least of which is the confusion that erupts from the setup of long division. Now, you could blame the fact that long division is the only one of the four that is not vertical. And that might be a valid argument. Of course, if you watched my previous Rogue Math video, you would see that I'm advocating for multiplication to not be vertical anymore. In fact, I'm advocating for it to look a lot more like long division in appearance, with a two-dimensional frame. The problem with long division, in my mind, is not the fact that it's not vertical, but rather the fact that it's backwards. And I'll get into what I mean by that, but let's start with what the common issues look like from the students. The first is confusion about setup. I mainly deal with 6th and 7th graders who are starting to grapple with the idea of converting fractions into decimal form by way of long division. And as such, these students no longer have the crutch that they might have had in elementary school of you put the big number in the box and the little number outside the box. And it's always disheartening for me to have to teach them for the first time that no, you don't have to put the big number in the box, you put the first number in the box. And I know in the back of my mind, here I am teaching them put the first number in the box when clearly the number in the box comes second. Really? Like, nobody thought of that? Well, that's why I'm doing my Rogue Math video, because somebody didn't think of it. Incorrect verbalization and conceptual confusion are two other big signs that the reversal of the numbers is having an impact on the student's ability to comprehend what they're doing. They say it wrong. They say 6 divided by 120 rather than 120 divided by 6. It creates an uncertainty in them about what is being divided by what. And where there once maybe have been confidence, now there is merely fear and apprehension. Other issues that might occur, skipping empty places, that is a drop in the bucket in comparison. And I think if we get the first big hurdle out of the way, it'll be easier to address smaller issues like that. Confusing the answer with the remainder is another one that comes up decent amount. What I mean is that when a student is forced to think about the answer number and the remainder number at the same time, it can cause issues, especially with those with attention and focus problems. So, for example, if a student is forced to find out how many 8s you can get out of 70, they will simultaneously have to think of the number 8 and the number 64. And oftentimes that can be difficult for them. So I have been working on ways to maybe facilitate that situation for those specific students. And I'll get to that at the end. And then, of course, hatred, fear, and avoidance is a problem in itself. And it's a common one. And that's the real big issue, is that students don't want to do the long division. And oftentimes they are going to get the wrong answers on problems because they are hoping they don't have to do long division to solve the problem. And so they don't. They do multiplication instead because that's easier. And of course, that's the wrong thing. They were supposed to do division. It's happened so many times. So with that in mind, how do we fix this problem? Well, there's one big fix. Dividend, then divisor. Dividend, then divisor. Dividend, then divisor. To put it simply, put the dividend in front of the divisor. When you look at a fraction, the dividend is on top. The divisor is underneath. When you look at a division problem with the division sign, the dividend is in front. The divisor is after. why should the setup for long division be backwards? It shouldn't. So dividend, then divisor. Facilitating the thought process was another thing. Trying to fix that two numbers in your head at once issue. So I put some work into that. But no matter what, I wanted to have some restraint because I knew that long division is a pretty good process. It's efficient, it is fast for those who understand it cleanly and don't have any confusion or apprehension. So I didn't want to change the process. I wanted to keep it the same, but just eliminate the confusion. Dividend, then divisor. And so when all was said and done, I ran through a bunch of different ways that I could accomplish this. And to be honest, I settled on the simplest and most conservative fix of all of them. And that was simply to just reverse the order of the numbers and do nothing else. So this is my great rogue math long division, which really just seems like common sense. 2001 divided by 8. 2001 goes in the box. 8 goes outside the box. In my case, though, the 2001 gets written first, and it's on the left side. The 8 is on the right side. And for most of your long division processes, this will have absolutely no impact on the student's ability to do it. It doesn't even make a difference at all until you have to deal with decimals. And even then, I'll teach you why it's not really that big of a deal at all. So let's go through the motions first of all. The process is exactly the same. Starting with the big numbers, 8 can go into 20 2 times. You subtract 16, and you have, 4 left over. Drop a 0. Now we've got 40. We can get 5 eighths out of that. Subtract all 40. We've got no remainder. We can drop down a 1. Oh, we can't get any eighths out of that. And so we're left with our 1 remainder. Now, at this point, if you're looking to make a mixed number, this is really easy. Here's your remainder. Here's your divisor sitting in the perfect spot already. You can just stick your remainder right there above the divisor. You can teach the students to do that exact thing, and they can have their mixed number sitting right in front of them, 250 and 1/8. So what about if we have to go into decimal form? Well, yeah, for those of you who get a little bit sad about the inability to add more zeros to the original number, I'm sorry, you're going to lose that little bit of conceptual ability. So you are going to have to rephrase what you do afterwards. It's not going to be bring a 0 down. Instead, it's going to be add a 0 for free. Is that really such a big difference? It's not that big of a deal. So you tell them to put their decimal point, and look, we have a nice visual cue. The decimal point goes right over the edge here. And then you can add a 0 for free, and then you can continue on to the next place value after the 0. We end up with a 1, minus 8, we get 2. Add another 0 for free, we keep going. We get 2 out of that, minus 16, we've got 4 remaining. We can add a 0 to that, we've got our 5, and that takes care of the rest of our 40. So we end up with 250.125. As you can see, the process is absolutely identical. The numbers are reversed. It fixes the problem in the simplest, seamless, and with the least amount of reteaching required. I've taught this to plenty of children. It has been seamless. It's always funny for them to initially tell me you're doing it backwards, and then for me to retort to them, no, you're doing it backwards. And then to teach them how to do this. And they end up being very grateful in the end. All right, so that brings me to the extra little bit, which is tally long division, which is a scaffolded addition to the long division process that you can employ. So let's start with the same exact problem again, 2001 divided by 8. And the way the tally gets involved is that it allows us to use our hands to put the answer down, freeing up our minds to just think about the remainder number. So in the case of accomplishing this problem, if we're going to find out how many 8s we get out of 20, what I teach the student in this case is not to think about how many 8s we can get out of 20, but rather to just start counting up by 8s until we reach 20 or get as close as we can without going over. And as you count up by the 8s, you're going to put tally marks down. So I would just have them do it underneath the 8 over here. I would go 8, 16. And that's as far as we can get. The only number that the student has to think about in their head is the 16. They don't have to think about the 2. Their hand wrote down the 2. They don't have to think about it. So they just think about the 16 and do that, and they get their remainder. And then they keep working. They put the 0 down, and they start a new tally for their new place value. 8, 16, 24, 32, 40. What number did I get to? I got to 40. Subtract 40. I have 1 remaining. Well, I can't get any 8s out of that, so I'm going to put a 0 for my next place value. And then I can keep going. I can turn that into a 10. I can get 1 8 out of that. Minus 8. I got 2 remaining. Stick a 0 onto that. And yeah, I might have to start pushing my tallies over if they, in order for them to keep their distance from my workspace, which is starting to encroach in their territory. But it's not that big of a deal. Put 2 here. Minus 16. Got 4 remaining. 40. Another 5. And I'm done. Took care of all my remainder. Now, after the fact is when I start looking back and I get my answer. Now, you can teach them to put their answer up top. But the key here, I forgot my decimal while I was doing this. My decimal goes right there before I started adding zeros for free. But I can start interpreting my tallies as digits. So my first digit is a 2. My second digit's a 5. My third digit's a 0. Then I have my decimal point. And then I have a 1, a 2, and a 5. This is not something that I teach to a general ed classroom. It's something that I teach individually to students who need that kind of scaffold. But I have had a few select students who have been grateful for this additional help to take some of the strain off their minds and make the long division process a little bit easier for them to digest.